I think that there are some other students from other disciplines as well. So my name is Lakma Rupasinghe, and my specialties are cyber, network, and machine learning. So the best thing is to like when you're doing the lectures, I'm anyway recording this, but if you can, one or two people, or at least one people can be unmuted, that'd be much better. So otherwise, I'm talking to a dead crowd, so it will be very difficult to continue. So if there's anyone who is having a bit of a silent environment, can you please unmute yourself so I can just keep on talking to at least that person. So then we can have it going in a rotation, so we can change the next day somebody else can be. So I think Chaturanga is a bit noisy, your environment. You can, of course, if it's all right. Uh, if there's anyone who is having a bit of a silent environment, you can unmute yourself. Can you guys hear me loud and clear? And also, can you see my screen? Hello? You can, no? Chaturanga, can you hear me?
Yes, sir. We can hear you and see the screens both.
Okay, that's fine. Okay, so next time onwards, ask someone to be unmuted. So yeah, today we'll try to manage. Okay, so now this module is basically normally do you get this outline? So I will upload your LMS today with even this lecture, so you guys can basically check it again if you want to. Now, so normally do you get this module outline, or the lecturer gives it to you? You can just put in the chat, right? It's hard for you to unmute yourself. Just use the chat. Yep. You get the outline normally in somewhere like LMS. You guys have a bit of a delay to speak up, so just type it in the chat. So otherwise you're wasting the time. Yes, it's uploaded to the WhatsApp. So Sakuni, is it done by the lecturer or is it done already? Is it there already? Okay, so, okay, Chaturanga, thanks, right. So I will give it to you, meaning I will create a PDF out of it and share it in LMS. So that I'll do today. Right, and okay, so when you look at the course outline, and I believe that you are third year, second sem students, okay, and 2 credits, and basically 25 hours of theory, so already 30 hours of lecture and tunes practicals, and 70 hours of independent learning. And this course mainly have 2 pathways or 2 main areas. One is distributed systems and then cloud computing. Probably first one would be the kind of the foundation for cloud computing, which are distributed computing or distributed systems. So the first learning outcome is to get the principles of distributed systems and of course internet applications. And then second would be implement a distributed application. So you have to do that, right? It's in C++ or Java, but let me probably see whether we can do it from a different language. There are so much of better choices these days. There's one called Rust. So Rust is better for performance and scalability and security. So you might jump into that, or even Python is good to learn and probably to simulate. And then third is discuss the design issues to publish, subscribe, or peer-to-peer networks. So there are so many different types of networks out there. Yeah, so that can be also interesting. And also illustrate the fundamental understanding of cloud computing. And that's really, really important these days, guys, because cloud computing is the thing, So everything now is based on cloud computing. So everybody, like the industry, when you go to the industry and they require the knowledge, like you can't go to the industry and learn it. So once you go to the industry, you have to know it, right? That's probably how it works. So you have to do your certifications. It's much better if you can do one or at least one certification before you go to the industry. Whether you're going to do development, whether you're going to do networking, whether you're going to do data science, whether you're going to do whatsoever, even security, I think having a good cloud fundamental would be definite. And also again, commercial web services, that does mean Azure Oracle, and even now there's Alibaba Cloud. So there are so many different choices. I think so. What we're going to do, we'll keep the distributed concepts. Probably now we might get around 10 lectures, and we probably have 2 to 3 lectures on distributed systems. Then we'll jump into more on the cloud stuff. I think that's very useful. I do cover all these things, but still I think this is more valuable because it's heavily used now. Heavily used. So there are so many good choices. Azure, AWS, or even Google Cloud is also quite popular. But I think we can go into all this, but the majority of would be on I think AWS, and I think that's quite a kind of a competition between Azure and AWS. But again, saying that some of the countries have different preferences. Even Oracle is so famous in some places. So let's see. So don't worry, the same would be like all the basics would be same. Just the some of those the way how that can be implemented can be a bit different from different cloud provider to the other, right? And then of course we'll have lectures Friday, I believe, 2 to 4. If there's any changes, it's beyond this hour. This is Saturday 3 to 5, and we might need to do some practicals for this. So we might need either guided labs. We can use Quick Labs a lot. I don't know whether you have the access to Quick Labs. So Quick Lab is one of the really great choices to learn cloud computing. Let me show you Quick Labs if you've not seen this before. Okay. Right. So this is Quick Labs. I do have access to Quick Labs. I can of course demonstrate so many things on Quick Labs. But if you don't have access to that, we'll try to find a different way to do it. So if you go here, so let me log in. So this is kind of a very interesting set of practicals are here. So you can see if you go to the catalog, there's plenty of different practicals that you can do, and some of them are free actually, right? If you go and look at from this end, I think let me look here. So you can do like hands-on lab quest. They are like kind of quizzes sort of, and of course it has Google, Amazon, right? Of course this is a Google product, so you might not find Azure here, Microsoft here. And course is there, so there are different courses you can follow. And there were some free also. I'm not really sure. Let me check. Maybe there were some free versions or free apps. Not really sure which is available now. But if you go and access this, what you call as Microsoft student, what do you call this? There's an option called student. I'll show it to you. If you have access to Microsoft accounts, there's a option where you can get some free credits for this one. Yeah, so don't worry. We'll be doing some of these things much easier to do it. Let's see, right? So some of those labs are pretty important, like Kubernetes and all that. It's quite interesting. So we'll go into those as well. So I will of course do some labs in not only from cloud, like I'll try to do some DevOps also, which can be very useful. So as an example, JIT and Kubernetes, Docker, so those are quite interesting, right? And some of those I will upload also. You can have a look at them because it's not in this kind of, we don't have time to do all that. So I will do some lectures, recorded lectures, and upload to LMS, so you guys can have a look at it, right? So that is done. Okay. Okay, right. And then the marks allocated, I think this is very common for all the other subjects, I believe. CA is 60%, sorry, 40%, and final assessment, which is probably exam, is 60%. And there's a project and assignment. I'll try to add these together and probably give you a interesting project. So next week, probably we can talk about it. And these are some reference materials. So this Tannenbaum's book on distributed systems is very popular. So probably that also you can look at, and also some cloud references. Right. Okay. So that's about how it would go. Right. Any questions to at this point? Any questions? Nothing? Good. Okay. No questions, guys? So if you have any questions, you can obviously ask in the chat. Nothing yet, no? Okay, good, good. So yeah, any question? No. Can you guys hear me clearly? Just put in the chat. So that's why I wanted to have one person at least unmuted so I can quickly talk to them without wasting time. So just someone please put in the chat whether you can hear me clear. Some people are still coming. Thanks, Sakni. Thanks. All good. Right. So then we'll go to the content. So this will be, I'll start with the uh, cloud concepts. So this can be very useful. So now, if you look at the idea of cloud, right, or the cloud computing, right? So this is not new, of course, right? So this is not new. This is quite old. So when the networks were set up a long time back, from the 60s, they realized there's a need to, or there was a need to keep things in the cloud or this environment where we can access. So mainly cloud computing popped out because the idea of sharing, the possibility of sharing. So if you can go a bit into the past. So let me get the whiteboard. Yeah, so now early generation networks, right? So probably you have about a bit of routing, switching and all that. So when the network was created with routers, right? So they realized that, of course, some of those resources can be shared. Early generation networks had these printers, right? In the network where you can have a printer service. So this is a hosted service, right? So that idea of these web services, microservices, all that idea came long time back. So printer was like a hosted service, right? So that was in one particular location in the network where anybody from anywhere can simply access it without much of a problem. So there are nodes, users who can basically access the printer to the routing path. Right? So that was not a big deal, right? So the idea was very clearly been implemented. So printer servers were there, file servers were there. So only thing was like this was in that the vanilla model called client server computing. So you have several clients and printer was hosted as a server. So this is called the client server computing. But later on, there were so many different models being introduced. Even that's where you find these distributed computing models coming in. It's not only client server, so it can be server to server, client to client. So there can be many different models being established, right? So we'll talk about these models later on. But these models had one particular objective, which is to share things. Now, as an example, we have something called parallel computing, right? PC parallel computing. So the parallel computing, the whole idea would be, now you have a network where you have several processors in different machines. So end of the day, you will be able to kind of have a network of processors, right? So network of processors connected. So you go on to run a job, kind of a process job, where it can be a bit bulky. So this is like finding, say, a DNA strain. So that needs a lot of processing power. So that you can basically submit it to this parallel computing cluster using an algorithm like MPICH. Right? So we're going to learn this as well. Pretty interesting algorithm, MPICH. So message passing interface, MPICH, right? So this can be used to basically share these resources. So this is the model which was there. Now what suddenly happened, right? So this because this idea was there, so everybody wanted this. So what happened at one point, there was this option because the network bandwidth became very, very big. You had a quite a big network bandwidth created by this fiber and so many other interesting stuff. So now your bandwidth is quite big. Now you can send so much of data in this. So now your shared services can hosted anywhere in the world without the limitation of geography, right? So because of that, actually the possibilities, endless possibilities of network improvements provided us a option to do this thing called cloud. That's really why it was named even as cloud, where it's far away, right? The cloud is far away, right? So that's the same logic. So this was there for almost several years, 30, 40 years. These things were there, these things were there, but now suddenly same logic being applied and was used in the cloud computing. But because it's so distant away, it's distant away, so now you don't have a problem because you can just say cloud computing. So suddenly now you can go to USA. This is United States, right? United States, and we are here in Asia, right? And from here you can basically access some servers. So you go through the CME cable, it goes like this, and some go to the Pacific and connect to the US. And then there is a Facebook server farm somewhere here, or Oracle server farm, or Azure server farm, and you are getting connected to the cloud service. So it's far away. It's like several, like thousands kilometers away, but the round trip time can be few milliseconds. So that won't be a big issue, right? Under several milliseconds, you can access your cloud service even in US. And also there's a quite fascinating network technologies where this bandwidth can be shared, as well as load sharing, balancing, and also it can then probably route it back to Calcutta or somewhere, right? And you can get your work done. So all these facilities are provided. So hence we get that possibility, endless possibilities of working with cloud computing. So that's where we say call it as cloud computing, because it's a bit far away. Right. So this is like this is not new. This was there for a long time, but now because of the unlimited bandwidth and also some improvements in the network technology like MPLS, some BGP technologies, right? So now it's so accessible, right? So this is so accessible, and also improvement of the software stack also allows us to have much of transparency. So as an example, like that if I go here, right? So there were days. Now see if I go here. So now I think you all use Netflix, and Netflix is so popular because HD can be basically okay, HD data can be streamed without much of problem. So this is also cloud, right? Netflix service or somewhere. This is cloud, and so things can be streamed very quickly, right? Right. So that's the idea. So that this provides for endless possibilities for video streaming. So this can be the most hardest one, right? So videos takes a lot of bandwidth, a lot of data, and they have to do a lot of processing, right? But you can get HD. So I'm not running HD at the moment, I believe, but still I can if needed to be, or I can do 4K. Right? That's also possible. I know that people are watching 4K movies over the internet these days. There are some problems in Sri Lanka, but I think it's not impossible to do that. Right. So these are all parts and partial of cloud computing as well. Right. Any questions, guys? Any questions? Any questions? Okay, no questions. All good. All good to this extent. Are you guys okay? Sakuni, are you okay? Are you following up? Yep. Anything you want to clarify? Okay. Thank you, Pechala. Okay. Good. Good. All right. Right. So we'll go to the next section. Right. So hope you are clear with this concept. So let me take you to why cloud computing, right? Now there are so many reasons why we should use cloud computing, and there are so many very positive and very true reasons why you have to use cloud computing. So we go one by one. So as you can see, there are some uh, comments given. 70% of budget to keep it IT running, 30% available to create new value. So this is the biggest problem now. Cloud computing provide you the freedom to come up with better budgets, or like saved budgets. A lot of people are actually spending money on budgets, IT budgets. So what happens is you spend money on budgets, so there's no budgets for you to create value, innovation, research. So what will end up happening, you will be in the same position where you like 5-6 years ago. But when you can cut down the budgets and saved your budgets for creativity, so you can do better things. That's what they are saying here. So now we'll go for example. So this is very common example that everybody sees the value of cloud computing. Say you're Virtusa, and then you have to do a project where you have to order like 20 computers because you want to have a cluster. I say this is a machine learning project, so you have to have 20 computers, and normally say if you don't have the computers at your office or at your place, you have to order them. So ordering 20 computers in a country like Sri Lanka would take a bit of a time. So to call for tenders, not private organization, but if it's a government organization, you have to call for tenders, wait for some time, get the bids and work it out the plan, and then you have to select the vendor, then you have to make the order, check your feasibility, and then probably call them up, and then you get your computers here. Then now you have the computers after probably 2-3 months, right, down in the line. So it might take 2 months even sometimes. I can remember I ordered a kind of a 50 computer lab, and it took almost 4 months to arrive from China. So it's quite disastrous, right? And then we ordered 20 Mac computers, iMac computers. Again, it took more than 3 months. So disastrous. Right. So once we arrived, anyhow, we got the computers at our place. So what we have to do normally is you have to set up a small lab, or with all these facilities like AC should be there, right? And then you have to have backup power. You have to have a generator or UPSs, right? And then you have to do structured cabling, right? So of course you have to do structured cabling, and you have to have desks, chairs, right? People to work. Obviously that should be there, and then the wiring comes in, and then of course there are so many other things. And you have to maintain the computer, then you have to install operating systems. If it is genuine computers, you have to buy like say 30 licenses of Windows, and they have to install all the software. Like it's a lot of work. So this might obviously take clearly 3 months to get things done. Now see, when that is done, at like next month, client says we want to test it for 100 computers. Now what to do? Are you going to scale this 20 computers in 100 computers? Would it take another few months? No, it's very difficult. This is like a hypothetical situation. But rather, if you go to a cloud provider, you know how simple it is to get 100 computers or 20 computers? It's click, 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 right? You make 3 clicks, 2 and 3, with the management platform provided by AWS or Azure. You can simply get your computers, right? You understand? So it's like probably few minutes or max 1 hour maybe, right? So with the payments and all that, and also, and you use it, and now after 1 month you don't have to use it anymore. You should just let it go. Now what happens in this situation? You don't use it anymore. So what to do for this 20 computers? What to do for the lab? What to do for the wiring? What to do for the AC? Cost for everything that you own, right? So there's a cost for the ownership. All right, are you clear about it? So there's a cost for the ownership, right? So now in this case there's no ownership, so there's no cost. So you save a lot of money, right? So you save a lot of money in this situation. All right, so this is the value of cloud computing. So just compare these two options. So how much money you can save from this? Only disadvantage is you might have to have a good internet connectivity, and also sometimes so because you don't have the right to some of those agreements or some of those say infrastructure, you will not be able to do so many things. So that's probably one of the the issues, right? Other than that, everything seems to be fine. So I hope that you understood the example, right? So going back, So then it says weeks of planning, justification, and deployment, and then we are stuck it for 5 years. So once you get your computers down to your place, you're stuck it for 5 years. You can't just throw it away. That's a problem, right? So even if our needs change in month, and most of our legacy applications are stable and predictable. So that's another one. So they would say they have the old applications, they will never improve. But think about cloud. So today you are working with Windows 10, and now suddenly there's a new improvement. So next time when you log in, you get Windows 11, 12, or something like that. So that's another advantage. Right? Okay, so those are some of those value additions for cloud computing. Now, if you look at these challenges, IT challenges, right? So this can be clearly, right? These challenges can be overcome using cloud computing. Think about globalization, right? Think about now you guys wanted to do some project, kind of a startup, right? Like if you watch that Silicon Valley startup, they create a video server, right, where you can do compression or uncompressed video, like in Netflix, right, where it be delivered to all over the world. But you started in US or Sri Lanka, so now it's okay. Everything works fine. But see what happens when your customers grew, and then you have to serve your European region. So now Europeans are coming to your server in here in Sri Lanka. It might take a bit of a time. So what you can do is all these servers can be hosted in different places, different cloud environments, different clusters, different regions, different zones. In cloud, you have all this terminology. Now what happens? So everything could be kind of distributed into different clouds in different places. Right? So some can be into Russia. So now your clients in Russia, Europe region wouldn't have a problem of accessing that. So the globalization is inevitable. So when that happens, you should have a system where it can be scalable and also support any number of clients. And aging data centers, very big problem. So now see, think about your computer, and now see, like when you stuck with the computer, when you buy a computer, you're stuck with the computer, right? You can't just change it the next day, right? So even next day you get a new game where you can't play with 16 GB, right? So then still, but you have to, just forget about it and use your computer. But it's not the case if you use a cloud. Right? So anytime you can go for additional resources, and this is pay per use. If you use it only, you have to pay, otherwise you don't have to pay. Right? And also storage grows immensely. Right? So you're talking about terabits, right? So how do you manage such? So if you have S3 buckets uh, in Amazon, you just deploy them. So one number of, so you can get any number of buckets where you can have expanded storage. So storage can be expanded pretty quickly. And remember, these are scalability options where you can do things faster. Application explosion. Now see, like there are so much of different new applications coming in. So you have to get ready, right? And then I talk about cost of ownership. We talked about it. So anything now, these days people don't buy houses. Why? When you buy a house, you have to pay taxes. But if you rent a place, if you know exactly what you're doing, so you don't have ownership. And you don't buy cars in some countries, you just use, like there are car clubs, you go to the club and take the car. So this won't work for everything. Now say, as an example, when you have your family or you have a wife or a husband, then there's ownership as well. So that will never go away. So that's something not business related. So that, but remember, that's also comes with the cost, right? Even the marriage comes with a cost, right? And then acquisitions, right? Acquisitions is like when you get companies together, so then how can you integrate those things? So it can be also difficult, quite difficult. So that's cases, these are all challenges. So you see a silver lining using cloud computing. So that's why people do use cloud computing for this set of given situations. I hope it's clear to you guys. So any questions? So this is the real need of cloud computing. Ask your questions. Okay, any questions? No questions. Good, no? Either you understood everything or understood nothing. What is?
Yeah, I'm Keshila.
Yeah, yeah. Apeshila, sorry, sorry, very sorry about it. Okay, thanks for that. Okay, thanks, Peshila. Any questions? So we have Peshila, we have Mekala, right? Okay, we'll continue. Right. When you take to the next slide. Now, so cloud computing, you have given a definition. Now, guys, it's very difficult to give definitions. Thanks, Sakuni. Okay. No, it's hard to find definitions, right? Because different people have different concepts related to cloud computing, but this is quite good from NIST. I don't know whether you are aware about NIST. So NIST is one of those places where you will get a lot of knowledge. So that is National Institute of Standards and Technology. I would recommend you to create a login also here because there are so many interesting areas where you can work here. Obviously, you will find different standards where you can learn so many things. So if you search here as cloud, so this is actually for some time they started selling things, but now again they have opened it up. Right. So you can find a lot of documentation, good write-ups about cloud computing. So this can be pretty handy when you're trying. Yeah. See, as an example, quite interesting set of documentation projects things where even you can work with these guys. You can go and kind of contribute your knowledge, and that can be good for your portfolio, right? So that's a very good place. Anyway, coming back to the definition, it says model for enabling ubiquitous. Ubiquitous means like everyday, right? Everyday things. Convenient on-demand network access. So see, like on demand, right? When you need it, you access. And also it's very convenient to a shared pool of resources. So I told you the idea is shareability of configurable computing resources. It can be servers, storage, networks, application services. So there's a kind of a stack here. So you can access server level, or you can access storage level, or you can have a network level or application level or services. So we later on understand how this works as a stack. Don't worry right now, you'll understand it. So this can be, of course, taken as different type of resources that can be rapidly provisioned. So provision is you are getting deployed at your place. So you know how quick to kind of spawn a virtual machine, right, in the cloud, or you should not say a virtual machine, but a cloud service, cloud machine. It's very quick, right? It's rapid. It's so rapid to provision it. Provision is like setting it up in the cloud, released with minimal management effort. You don't have to do much. You go to the kind of management interface, click, 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 you get done with your whatever service. It can be cloud, it can be storage, it can be a real computer, a server, or it can be a software, right? You have some software as a service. So you can set up a software like a ERP and you can use it. So there are many options to select, right? So these are some characteristics for the cloud. It's on-demand self-service, right? So self-service, like you go to the shop and say, okay, they would say self-service. You have to go there and collect. Now go to Pereira Sons, you have self-service. Now when you sit, there's no, somebody coming and asking, sir, what do you need, right? Madam, what you need. So it's self-service. You have to set it up and you got to go and access it. And it's on demand, per pay-per use, right? So when you require, you go and use it. And broad network access. So without broad network access, you will not be able to use the cloud, right? For a long time, that was a problem. Like countries like Sri Lanka, we haven't had a good network access, but now fortunately we have some good network connectivity, so we can use cloud without much of a problem. Resource pooling, so what they do, it's their very common characteristics, right? So they will obviously do resource pooling. So what would happen? What would happen? So they can. Okay, so what they do is they have set of resources in their pool, 1, 2, 3, right? Now the thing is, when you look at a given instance of time t1, say all 3 machines is utilized, right? So this is utilized, and this is utilized, and this is utilized. Everything is utilized. But at time t2, right, maybe 1 is not used, 2 and 3 is used, right? This is used. So what happens is somebody else now can use, right? So this was used by a single client, right? So client 1, now client 1 uses these two time t2, but the space of 1 or the computer called 1 is not used. So obviously another client can use it at c3, right? C2, sorry, C2, right? At time t2. At time t3, now what happens at time t3? Now C1 like doesn't want this anymore, right? So C1 doesn't want this anymore. So what would happen is C2 started using them altogether. So now at this time t2 or t3 option or t3 time, this is used. So now we can see at different time intervals, this is shared. Same resource is being shared. So actually try to understand this one is a real computer and end of the day, no? So this real computer is being used by different class at different time intervals. So they have a scheduling algorithm where they have sort of even predictive machine learning being used. They know exactly how this is being used when they have the data. So then at that point, they know exactly how to serve the clients, how to serve the client. Is that clear, everyone? So this is how that cloud model works. I would say very profitably or high profitability. So otherwise, like, so if you think like, so there can be million clients working with Google Cloud or MSN Cloud, do you think there are million computers? Not at all. They might have 10,000 computers, but they know how to share it among many people, right? So as an example, they have an environment where they would have a kind of architecture, kind of this sort of layer which have resources. This resource would be 10,000 GB, right? But they can serve 100,000 clients, right? With this 10,000 GB, that won't be a problem. So ultimately, when you look at how much you have given, it's like you have given altogether virtually you have given more than 1 million GB of data, but actually you are not having that 1 million data in your cloud environment in Google Data Center. So that's the difference between, or that's how really they make profits out of cloud computing. Hope it was clear to you. Any questions, guys? Any questions? Okay, all good. And I would really urge you to, I will put it in the LMS as well. Go and check this nice set of videos. There's one called Google Data Center. So these are pretty cool videos. So this one is really good to look at, and Google Data Center 362. So I'm not going to run any of these things, right? Yeah. So please watch some of the, and this is a very good one, Facebook largest data center, right? So you can get an understanding about how this works. And also this is also good from Cloud Next. I'm not going to run the video, but once you go here, you can get a lot of data. So at one point, I think several years back, there was a kind of a slight decision from Google to have it maybe even in Sri Lanka, because Sri Lanka is having very low cost power using hydropower. So they were because the problem of data centers is you have to spend a lot of money, right, for the power, right, because you have to have backup power and everything. So you have to spend a lot of money on power. So they were looking at having it in very open environment. You can see, like, so there's no much other things here, because they either put it in deserts where a lot of strong winds coming, or where it's next to a mountain edge where say a lot of cool wind comes in. So say this is Everest somewhere here. So they would really like to have the data center like in a valley near to that, because there are a lot of cool wind coming from the mountain edge to mountain edge to the floor here, right? So that can be very useful to get natural wind, and that's also another option that they use. So the problem where they couldn't implement it in Sri Lanka because we didn't have the good bandwidth to Nuwara or wherever. So we we had a very weak bandwidth in Sri Lanka. Even right now, even if there was a proposal comes, I think we are not ready because we don't have fiber in such areas. Yeah, so please watch this. I think we have to create a different, I don't know how many of you will end up doing this course. Have you all taken the decision to do the course, or you are still checking? Peshala, have you taken the decision? I think you people here, I think for network security students it's mandatory, but others they are not mandatory. Peshala, are you there?
Sir,
Have you guys taken the decision? You are still
no,
looking at the option,
no,
no?
yes.
Yeah, so but meantime create a WhatsApp group. I think we have a WhatsApp group for the network security students, but for this class please Chaturanga, can you do that please, so then I can share the resources.
Sure, sir.
So yeah, thanks. So whoever wants to do the course, later on they can change, that's okay, but create a WhatsApp group so I can keep sharing the important things like this particular video, which can be very useful. Right. And also, like, I just really wish that you guys can do one of these courses. These are freely available. Maybe you don't have time to do, but still, I find this quite interesting, especially this series. I have access to this. Maybe you also have access. Google Cloud. This is quite, yeah, this one is really good. Cloud engineering with Google Cloud, data engineering with Google Cloud. So this series is pretty neat. So you guys can, I think, do, I have access to all this, I think all the 4,000 courses. But if you want, I think you can do audit, no? But I have full access, so I can get the certificates as well. So it's 7-part series, but by doing this would be good. So if you don't have access, don't worry, I'll share some of those resources here, what you see. And end of the day, you get a kind of a certificate like this. And this is really neat because I think the Google Cloud is something you can study, and because it's open source mainly, the software stack, but some of them are not open source, you know, like the project called Omega, which is later on became Kubernetes. That's not open source, but most of the things they give out for free, some of those services that they use and all that. So that can be pretty hot, right? So yeah, so if you have time, I think if you can go and have a look at those. So if not, I can run some of these videos. I don't think that's unethical.
Here are some of the proved the coverage of Kubernetes engine and throughout the course. Thank you for taking.
So they use a lot of Kubernetes in their cloud. So we'll try to understand that as well. I have a recorded lecture. I can host it even today, but let us see. So we might need a bit of slow moving here.
Hi, I'm Brian Rice, machine learning resources.
Yeah, so there's so much to learn here. So let's start anyway. Okay, so now we'll move on. So we talked about resource pooling and rapid elasticity. You can grow things faster. You can grow things faster using Google Cloud, or sorry, any cloud, because moving from 100 computers to 1,000 computers is like a second away, right? A millisecond away. And measured, everything is measured, metered. We say metered. So if you use it, then all you have to pay, right? So it's metered service. And then, okay, now you find this architecture, and there's a nice story behind this. Try to understand, normally you would not be able to build a cloud just a single day. It might take a bit of a time, but of course this is not relevant for cloud providers like Google or Azure, sorry, Google or AWS or even Microsoft. But normally even we can build up a cloud, but it's a kind of a journey. Right? It's kind of a journey. It consists of these architectural things. So I'll try to draw it up. Now, how it works out. Now, if you want to do cloud, that's another very important technology comes in. So that is called virtualization. So without virtualization, cloud can be easily something that you will not be able to implement. So virtualization is quite useful to understand, and also without virtualization, cloud would be impossibility. So can one of you explain what is virtualization? So how does this virtualization work? Yes, so how does the virtualization works? Anyone, please? What is virtualization? If you can answer one of those questions. Oops. Yeah, anyone please? So I have to name someone then, no? Yeah. Madhusha Jayaratna. Oh, I don't know whether it's Madhusha Jayaratna. Yes, Madhusha. Have you learned virtualization anywhere? Or to that matter, anyone? Supun Viduranga? Supun? What is virtualization? Can anyone tell me what is virtualization? Okay. The next day you can't be unmuted. Huh? All right. So now see, a virtualization is you will get the normal layer of a computer, which is the hardware layer, right? On top of that, you can have the operating system, right? You can have the operating system, and this is like very common. These are common things. So this is the OS. It can be Linux, or it can be Windows, or it can be any other. And on top of that, you can have something called hypervisor, right? So this hypervisor is the what you called as the virtualization layer. So the hypervisor knows how to imitate, right, operating system. So hypervisor itself works like an operating system. Right, so it talks to the operating system underline. If needed, it can talk to the hardware, right, directly, even bypassing the operating system layer. So then on top of that, without any problem, you can create multiple operating systems, because now hypervisor gives that we say transparency, or we say that illusion that you are on top of the hardware layer. So it's like when you look from here, look it from here, like this is your eye, you're weaving through that, right? So you look from there, actually what you are seeing is directly the hardware layer, not the operating system here, right? So you feel like you are working on top of your hardware layer. So this is basically virtualization. And why you made virtualization? Because you can obviously share these hardware resources. Normally, if you use just the operating system, you had to have 3 computers, right? Now, because of virtualization, you know that for sure, you can basically share your resources, right? Share your resources. So obviously you can start with sharing your hardware. So you find your hardware, right? So this single hardware, right? So this is one. So this can be shared now among several computers or several operating systems or several virtual machines, right? Previously you had used only one operating system, but now there's a possibility of using multiple. And see, again, the shareable principle comes in. So this might work with 50% of 50% utilization. This might work with 25%. This might work with 25%. So there is there won't be a case where you have 100% for all 3. Even though it's 100%, you can manage it, but still most of the time these are working with different utilizations. So then idea would be okay. So you don't really need to worry too much about. You can share things. So as an example, if I look at my PC, or I'm using a Mac here, so so if I just look at how my CPU is utilized, right? Let me check. Okay, so if I do a top, right? So you can see my CPU is utilized. Let's check. Okay, see, all together, yeah, it's basically 8